All right, so what we're gonna do is we're gonna look at solving these quadratics, and then we're gonna look at verifying it using a calculator. But we're gonna do that in the second video. So in this first video, we're going to follow these steps, and basically the first three steps is basically saying that if you take this quadratic equation, right, and you just set it to zero, now you can figure out what are the solutions for x. And so you may see this a couple of ways. You may see this as the f of x equals, and then put this equation, or you might just see this as y equals, right? And so it doesn't matter, like, to be honest, these are basically saying the exact same thing, to be like in layman's terms. Okay, so I'm gonna just use y equals plus 4x minus 12. All right, and so basically when I do my table, okay, like we've been doing. Okay, so by the way, everything that we're going to do in this first video is going to be by hand, right? So I'm going to show you guys how to graph this by hand and everything. All right, so if we just set our y to 0, so we're basically saying 0 equals x squared plus 4x minus 12, right? And so first thing you want to check for is, are there any GCFs, which there aren't, because our leading coefficient is just positive 1, right? So now I just look to my C terms, and I got to ask myself, um, are there products of negative 12 that will give me a positive 4, right? And hopefully you're saying to yourself by now, like, yeah, 6 and 2. And since the 4 is positive, I know my 6 will be positive. So basically you get x plus 6 and x minus 2 equals 0. And now your solutions for these zeros is x equals negative 6 or x equals positive 2. And so those will be your intercepts. Okay, so we solved our intercepts for this quadratic equation. Now, if we were graphing this equation, right? So let's say we were tasked to graph this, right? So again, we got y equals x squared plus 4x minus 12. And we've already said that our x-intercepts is going to be positive 2, 0. No, negative 2, 0. And positive 6, 0. Right? No, I'm saying those backwards, because our solution is going to be x plus 6 equals 0, or x minus 2 equals 0, which will make these both the opposite. So it's going to be plus 2 and negative 6. All right, so first things first, there's a couple of key factors when it comes to graphing quadratics. And the first thing you need to know is, well, what is your vertex? Okay, and your vertex is that point of change, right? It's where the graph change directions, right? And so how do you find that? Well, you find that by saying you're negative b over 2 times a. Okay, and this is going to be a ordered pair as well, and that's going to give you your x term, and to find the y, you just take the function of x, right? Like whatever that is, you just stick it into the equation to find your y. All right, so if we need to identify our A, B, and C, our A is positive 1, our B is positive 4, and our C is negative 12. Okay, so if I just take what I have, negative 4 over 2 times 1, that gives me a negative 2 for my vertex when it comes to the x variable, or I'm sorry, x coordinate. And then if I just stick the negative 2 into the function, negative 2 squared plus 4 times negative 2 minus 12, I'm going to get 4 minus 8 minus 12, which is negative 4 minus 12, which equals negative 16. So my vertex for this graph is going to be negative 2, negative 16. Okay, so your next factor is, what is your axes of symmetry? I'm going to just put A of AOS, right? So axis of symmetry. Okay, and this one is easy once you find the vertex, because your axis of symmetry is in the form of an equation of whatever your x variable is. I'm sorry, your x value is in your vertex. So basically, your axis of symmetry is going to just be x equals -2. Okay, that's the vertical line that splits the parabola in half. It's the vertical line that gives the parabola symmetry. All right. And so your third step is to determine how many x-intercepts you have, right? And so we already know there's going to be 2 because we solved it. But like if you wanted to really know, you can just do your discriminant, right? And what is our discriminant? Well, it's part of your quadratic discriminant. Well, it's part of your quadratic formula. It's just the b squared minus 4ac. Okay, and if this is greater than 0, then you know you're going to have 2 x-intercepts. Okay, if this is equal to 0, then you're going to have 1 x-intercept. And then if this is less than 0, like if this is negative, then you're going to have, for our class, for right now, you're going to have no x-intercepts, right? Like the line is, I'm sorry, the parabola is not going to cross the x-axis, right? And so if it's negative later on down the line in your higher mass, right, this essentially becomes 2 non-real x-intercepts. But right now, we're not going to focus on that. If it's less than 0, we know we don't have any x-intercepts, right? So we just followed this formula. And again, we would take our b, so we would take our b and square it. So we would say 4 squared minus 4 times, that's a, 1 times -12. That gives us 16 plus 48, which gives us 64. Therefore, we know, or we're verifying, that we have 2 x-intercepts. And from this point, you would work one of your, either your factoring technique, or you would you can do the quadratic equation to solve for the x's. All right, so now that we got that situated, let's go to our fourth step when it comes to graphing a quadratic equation. So next you need to know, like, what direction is the parabola going to open? And so direction. So we got step one, find the vertex. Step 2, our axis of symmetry. Step 3, our discriminant. Step 4, the direction. Okay, and so for this one, again, it's just look at your a term. Okay, and if the absolute value of a, actually it's not even the absolute value. It's just if a is greater than 0, then it's going to open up. Just horrible at spelling today. Open up. Okay, if a is less than 0, then it's going to open down. All right, so our a is +1. Therefore, we know we're going to have a parabola looking more like a U. Okay, and then lastly, we can know the width of our parabola. All right, and so to determine that, here's where I was thinking with my a. This is where if the absolute value of a is bigger than 1, then it's going to be pretty narrow. Okay, if the absolute value of a is bigger than 0, but less than 1, okay, then it's going to be wide. All right, so in order to typically, in order to graph a parabola, all you need is your vertex, and if you have 2 x-intercepts, perfect, your 2 x-intercepts, and then you can graph it, right? Or you can just find the parabola and then just stick values into the function to find other values, right? Stick values into your y function so that you can find other values, right? So if we were ready to graph this now, okay, and let's just say, so you would definitely need to follow you would definitely need to follow that those graph expectation sheet that you have available for you in your Canvas shell. Okay, but I'm gonna do this as best I can with freehanding this with a mouse. All right, so first of all, you will have your axes. Okay, and then you would of course label your intercepts. This is my X axis. This is my Y axis. Okay, then you would plot your points. So this is gonna be scaled at tens. Okay, and our first point is -2. No, it was +2, right? +2, 16 for our vertex. So we would say, boom, +2, 16. And then our x-intercepts was -6, 0. So we would plot that here and we would label this -6, 0. And then +2, 0. Okay, and then we would graph it now. Now, this is where you definitely need some sort of technology because you would see that will slowly get wider. And then you would come this way where that is getting wider. All right, so like I said, the next video we'll look at the calculator so we can verify that. All right, but let's go back because we have a couple more on here that I wanted to look at really quick to make sure we're understanding this. Okay, so question 2. Okay, question 2. We have this quadratic equation, 3x squared minus 11x minus 4 equals 0. So great, that's already set to our zero factor property. Okay, so now our a term is not 1, right? So I'm gonna just do the slide and divide method. So I'm gonna just slide and divide. Okay, and that method just says I'm gonna take my a term and slide it to my c term and just multiply. So I get x squared minus 11x minus 12 equals 0, right? And so now this looks very similar to question 1, right? Where I'm looking for factors of 12, a -12, that when I subtract them, they're going to give me a -11. And so if my C term is negative, then I know, and my B term is negative, then I know my factors have to be one negative and one positive, right? And so factors of 12, that's 11, is 12 and 1. The 12 is bigger than the 11. 12 is bigger than 1 and it's negative. Therefore, the 12 will be negative. The 1 will be positive. Okay, and I will be done if this is what I was factoring, but it's not. I'm factoring this. So now the divide part means I come back and divide by whatever my A term was. All right, and if I can simplify this division, then I just leave it alone. Okay, if I can't simplify, then I simply take the denominator and slide it back in front of the variable. So 3x plus 1. And now I'm done using the slide and divide method for factoring this quadratic equation, right? So therefore, my x-intercepts are going to be +4 and -1/3. Okay, so my x-intercepts 4, 0, 1/3, 0. All right, so next I need to figure out my vertex. So remember, my vertex is going to be -b over 2a. And then the function of whatever x is, right? So -b becomes +11 over 2 times 3, which is going to be 11/6. And now to solve the y in that, I just need to replace x with 11/6. All right, so this is going to be fun because it's a fraction, but oh well, we can work with fractions. So 3 times 11/6 squared minus 11 times 11/6 minus 4, right? And so 3 times 121 36s minus 121 over 6 minus 4. All right. And so 3 times 121 is going to be 363. So I'm going to move it up here. So 363 over 11 minus 121 over 6. I'm sorry, this should be over 36. Minus 121 over 6 minus 4. And so now for me to add and subtract fractions, I just need to come up with a common denominator, which at this point, I'm just going to use my calculator, right? So I'm just going to go to my calculator and I'm going to say, okay, what is 336 divided by 36 minus 121, 121 divided by 6 minus 4. Okay, and it's going to give me some type of decimal. And now I want to convert this decimal back to a fraction. So I'm going to just press my math key. And I want it right at option number 1. I want to convert this back to a fraction. And so I get 586 over 6. Okay, so my vertex is 11 sixes. Is 11 sixes over 586 sixes, right? Which this is going to just be a crazy one to graph. 581 sixes. Okay, so this one would be quite, like, without technology, this one would be just ridiculous to graph, right? Because this is basically 11 sixes is approximately 2, and 581 sixes is approximately what, 97 basically, right? So that's just, oh man, how we would have to scale this. This is why technology helps a lot, right? So now we can work our discriminant. So b squared minus 4ac. So our b term, so if we recognize our a is 3, come on. So our a equals 3, our b equals negative 11, and our c equals negative 4, right? So b squared, so negative 11 squared minus 4 times a times c. So we're going to get 121. 4 and 4 is a negative 4, negative positive. So this is going to be bigger than 0, right? Therefore, we're going to have 2 x-intercepts, which we've already found to be 4, 0, and 1/3 0. Okay, next, we know it's opening up because our a is positive, and since a is the absolute value of a is bigger than 1, we know that this is going to be a narrow graph or parabola, right? And so this one, we're just going to use the calculator to visualize this once we get back to this question. All right, and looking at the last question. Okay, so we have a special quadratic equation because that one, like once we use our zero product principle, right? We get 4x squared minus 25 equals 0. And why this is special is because 4 is a perfect square, 25 is a perfect square. Therefore, we have our difference of squares, right? And so this one is fairly, like, if you know your difference of squares, right, it's just fairly easy to solve because you just take the square root of 4, which is going to give you 2, and you take the square root of 4x squared, which is going to give you 2x, and you take the square root of 25, which is 5. And since it's the difference of squares, these will both look the same. They will just have alternate signs, right? And it's going to equal 0. Therefore, my intercepts is going to be negative 5 halves and 0, and positive 5 halves and 0, right? So now let's figure out our vertex. So follow our discriminant, b squared minus 4ac. Okay, so our b is just 0. So we get 0 squared minus 4 times 4 times a negative 25. Okay, so 0 plus, because I got a negative times a negative, 400. Therefore our discriminant is bigger than 0. So we're going to have two x-intercepts, which again, we've already found those. Those are our x-intercepts. Okay, so I think I skipped the vertex piece. Yeah, I did. I skipped the vertex piece. So let's find our vertex. So our vertex is going to be negative b over 2a. And then the function of x. Okay, and let me just go to a clean sheet of paper because this is getting way too sloppy. Okay, so we have 4x squared minus 25 equals 0. Okay, and we're looking for the vertex. So we're going to say negative b, which is negative 0, over 2 times 4, which gives us a vertex of 0, or x of 0. And now we're going to say 4 times 0 squared minus 25 is going to give us a negative 25. Therefore, our vertex is going to be 0, negative 25. All right. And so the direction in which this actually our axis of symmetry is going to be x equals 0. Okay. And now this is going to open upward because our a term is bigger than 1. The absolute value of 4 is 4. And because of that, we know that it's going to be a narrower parabola. All right. So back to graphing that. So if I was graphing that, we would say this is another one that requires a little bit of imagination because of that 0, negative 25 is our vertex, right? Which also happens to be our y-intercept, okay? Which you're always going to have a y-intercept for a parabola. You're not always going to necessarily have the x-intercepts, all right? And then we said our x-intercepts was 2.5, was negative 2.5, 0, and positive 2.5 and 0. Right? And then again, using technology, this will look a lot cleaner and a lot better. But our parabola is roughly going to look like so. All right. So hopefully this has helped you mainly with the factoring part, right? But kind of just taking it a step further so that you guys can start to see like what this is going to lead to as we start to graph. So I'm going to come back with another video, and now I'm going to just show you how to verify everything we just did by using your calculator. Talk to you shortly.